Determine the values of b and c such that the function f of x equals 3x squared plus bx plus 4 for x is less than or equal to 2 and x cubed plus cx squared for x is greater than 2 at the x-coordinate x equals 2 will be continuous and differentiable. To be continuous at an x-coordinate of 2, we need the two-sided limit as x approaches 2 from both sides of f of x has to match f of 2. The function f of x here is a split expression function. It does split right at the x-coordinate of 2, so we will need to work out the two-sided limit from each side separately. So we have the left side of 2 and the right side of 2 for f of x. Let's start with the left side limit. The left side of 2, which is less than 2, will make use of this expression. So that will give us 3x squared plus bx plus 4. We can now plug a 2 in for each of the x's. That'll give us 3 times 2 squared plus b times 2 plus 4. We have 3 times 2 squared is 4 plus b times 2 can be called 2b and then plus 4. 3 times 4 is a 12 plus the 2b plus the 4. And so we can put the 12 and the 4 together and combine them. So we have 2b plus 16. Let's look at the right side limit of 2, which means that we are greater than 2, and therefore we use this expression for our f of x. And that'll be x cubed plus cx squared. We can now plug a 2 in for each of the x's, and that will give us a 2 cubed plus c times a 2 squared. 2 cubed is an 8. 2 squared is a 4 times that c. The last thing we need for continuity is evaluate f of 2. And f of 2 will be the one that includes 2, and that'll be that expression there. And 2 gets plugged in for each of the x's. That'll be 3 times 2 squared plus b times 2 plus 4, which is the same result as the left-sided limit at 2. So this will once again become the 2b plus 16. Now these all need to match each other. To have continuity, we have to have the left side limit, the right side limit match, and then it has to equal f of 2. f of 2 already matches the left side limit there, so we really just need the left side limit to match the right side limit. So we have this result hold true. Now we can simplify this a little bit. One option is to subtract 8 from both sides, so we can say 2b plus 8 equals to 4c, and then we can divide by a 2 just to reduce the numbers a little bit, and b plus 4 equals to 2c. That's about as simple as we can make it for now. We will need to get another relation before we can solve it because there are 2 variables in that expression. And that's where the differentiability comes in. We are now going to look at the continuity of the derivative. Let's take the derivative of the function f of x. It will be called f prime of x. The derivative of the first expression will be 6x plus b. And that will hold true for the interval of x less than 2. We do not know whether it includes the 2 just yet. It has to be differentiable for that to happen. But we're going to force it to be differentiable. So we will want it to include the 2 because we're going to find the b and c that makes this hold true. And then the second expression, it has a derivative of 3x squared plus, bring the power down to c is a constant. So you multiply the 2 with the c and you subtract 1 from the power. And this will be true for x is greater than 2. To be differentiable is to be continuous on the derivative. And it's at the same x-coordinate of 2, so we have the two-sided limit as x approaches 2 from both sides of f prime of x has to match f prime of 2. And once again, it's a split expression function, so we will need to work out the two-sided limit from the left side and the right side separately. Let's start with the left side limit. The left side of 2 is less than 2, so we will make use of this for our f prime of x, 6x plus b. We can now plug a 2 in for each of the x's. That'll give us 6 times 2 plus the b. And 6 times 2 is a 12 plus the b. We can now look at the right side limit at 2. Right side of 2 is greater than 2. We will use this expression for f prime of x, and that will give us 3x squared plus 2cx. We can now plug a 2 in for each of the x's. That will give us 3 times 2 squared plus 2c times 2. 2 squared is a 4, so we have 3 times 4 plus, those 2's can multiply each other in 4c, so we have 12 plus 4c. We also want to look at f prime of 2, and that's going to be using the expression where 2 is included, and that'll be this expression here. So that we have 2 plugged in, and that'll be 6 times 2 plus b, which is going to give us the 12 plus b that we have for the left-sided limit. So the function f prime of 2 matches the left side limit, but we need the left side limit and the right side limit to match each other. So we need that we have the 12 plus b and we have the 12 plus 4c, and they have to be the same thing. Well, we can now subtract the 12 from both sides, and we have that b will equal to 4c. And that gives us two equations to work with here. We have this one and we have this one, and we want to simultaneously solve those. The second one is simpler. So we'll start with this result for b, and we can take it and plug it in for b there. So that will give us 4c plus 4 equals 2c. We can subtract 4c from both sides, so 4 equals to negative 2c. Divide both sides by a negative 2, and c comes out to a negative 2. Now that we have the c, we can go back down here, because b is just 4 times whatever the c comes out to. And 4 times a negative 2 will give us a negative 8.